Hello, everyone. This is Dr. Tidman. From time to time on my YouTube channel, I'll be posting short talks on some of the current research in Parkinson's disease, giving you a brief overview of these studies and then some applications that you might consider. Welcome to my channel. Please like, subscribe, and hit the notification bell so that you can be apprised of new videos when I post them. Today, I'm going to be reviewing a research study by Phillips and Piccard. My goal is to review some of the current research in Parkinson's and other neurodegenerative diseases, review some of the variables and the results of the study, and then try to relate some of the things they found to real life. I'm a clinician with over 45 years of experience working with people with Parkinson, and my goal is always to give you some practical applications. The title of the article was Neurodegenerative Disorders, Metabolic, Icebergs, and Mitohormesis. This is by Phillips and Piccard, and it was published in 2024. I had the privilege of hearing Dr. Phillips present this research study in August of 2024. So the elements of the article had a lot to do with applying these principles to a lot of neurodegenerative diseases who have some common things that they have in terms of symptoms and potential causes. So we know that Alzheimer's and Parkinson's, ALS, and Huntington's can be characterized by some similar areas of damage in the brain. We're going to call those the metabolic icebergs. The tip of the iceberg in a lot of these disorders are hallmark neurological symptoms, things like tremor, rigidity, gait disturbances, neurodegenerative regions in the brain that are affected similarly in these neurodegenerative disorders, and some protein aggregation, some abnormal proteins that are found in the brain in some of these regions. The bulk of the iceberg is the impaired mitochondrial biology. And you'll remember that mitochondria are the small organelles within cells that have a lot to do with energy production for the cell. It's multifaceted, the things that the mitochondria do, and they really have a lot to do with impairing cellular metabolism. Mitochondria have behaviors, functions, and activities that they do. And sometimes these are impaired due to a number of things we'll talk about in the base of the iceberg. So the base of the iceberg in Phillips and Piccard's analogy are environmental factors, which include modern industrial toxins, nutrition, cognitive, physical, and psychosocial behavior changes, genetic factors, and other things specific to some of the genetic forms of Alzheimer's, Parkinson's, and ALS. The authors propose that impaired mitochondrial biology has a lot to do, I'm going to move myself down here so you can see, with the mitochondria needing to be recalibrated or rebooted, for those of you who know that term, through a process the authors termed mitohormesis. This state can be achieved through strategies that facilitate an oscillation between stress and recovery. So the authors were theorizing that this process of mitohormesis can produce a stronger mitochondria, some the cellular structures that are more resilient and more adaptive, and that in neurodegenerative disorders, they've lost the ability to adapt. So it's a very interesting theory. So the mitochondrial iceberg, I'm going to move myself up here, has a lot to do with what the authors were talking about. And they present this iceberg analogy for each of these neurodegenerative disorders in their article. I'm just going to cover it in general. These tend to relate to all of these disorders. So again, the tip of the iceberg are the things you can see, the symptoms. Tremor, rigidity, gait disturbances, some speech problems, some sleep problems, fatigue, GI issues, depression, apathy, anxiety, some of those things that you experience on a daily basis. And of course, here's the bulk of the iceberg is mitochondrial dysfunction. The function, activities, and health of your mitochondria are impaired. And then some common causes you can look at in the base of the iceberg. Again, those environmental exposures like pesticides, herbicides, heavy metal exposures, pollution, a history of head trauma or concussion, nutrition. And then, of course, the least common at the base of our iceberg analogy are the genetic mutations. So in the article, they alluded to the ketogenic diet. I have a little slide here called Keto for Neuro, and it's what are the typical macronutrient ratios for a ketogenic diet? Well, typically, this can be 70 to 80% of your diet is composed of healthy fats. This very much harkens back to the ketogenic diet for epilepsy that actually was discovered over 100 years ago. For the epilepsy approach, you can have fats in the diet up to 90% of your calorie intake. Proteins you can see are rather moderate, 20 to 25%. And often in the ketogenic diet for epilepsy, we found protein ratios down at the 15% level. And then, of course, carbohydrates are the lowest, 5 to 10%. But on the classic epilepsy diet, you can find carbohydrates down at the 3% range. So what would be a good application, set of applications, according to the authors, on how you could use some of this information in your daily life? Well, a few of the things they talked about were reducing chronic stress. We know that stress taxes the brain considerably through the elevation of cortisol. Improve your sleep quality. Sleep hygiene techniques include things like reducing your screen time and caffeine intake after a certain time in the late afternoon, reducing light levels in your sleeping space, keeping the sleeping area cooler. These are some things you can think about for sleep hygiene. Facilitate your psychosocial connections to others, to community events, social events, and this has a profound effect on your tendency towards depression. Engage in challenging cognitive activities. We've heard this before. So learn a new skill or participate in a new learning activity, learn a new language, learn to play a new instrument. All of these things are things that challenge your brain and again, give it just the right level of stress, which may strengthen your mitochondrial functions. Limit your technology exposures. If you have to be on your computer for work, consider getting some blue light glasses that filter the blue light. Intermittent fasting. We know that fasting is a stressor for the body, but it could be a good stressor to reduce your glucose levels and improve your levels of blood ketones, which are important for brain health. Of course, limit your exposure to pesticides and herbicides. Try to reduce your overall inflammation. That means reduce the consumption of inflammatory food substances, processed foods. We call those food-like substances. They're really not foods. Reduce your intake of seed oils and sugars. Increase your consumption of healthy fats to raise your ketone levels. These healthy fats are things perhaps our great-grandparents ate all the time. Animal fats like lard and beef tallow, butter, MCTs that are found in coconut oil, and then some of your other healthy fats like avocado oil and olive oil. Control your blood glucose through restricting your carbohydrates to a certain level. Increase your daily exercise. Of course, we know exercise is good for a lot of things, but one thing that exercise does is it improves your muscle tone and the production of good muscle cell development. And the larger your muscles are, they can actually act as a glucose sink. In other words, it really helps with the control of your blood glucose levels. Of course, we know too, as you get older, maintaining muscle strength is critical to maintain your independence. So to summarize what Phillips and Piccard talked about in their article, neurodegenerative diseases such as Parkinson's, Alzheimer's, Huntington's, and ALS can use the iceberg analogy to illustrate causes and symptoms and some of their underlying pathology. Many lifestyle and nutritional factors influence mitochondrial health. The iceberg analogy is particularly useful in understanding Parkinson's disease and some of its potential mitochondrial origins. Practical applications they talked about included reducing processed foods, seed oils, and sugars, along with limiting simple carbohydrates, reducing total body inflammation, controlling your blood sugar, and lowering your insulin. Exercise can provide a proper amount of stress on systems to make them more adaptable. And this is really key to maintaining mitochondrial health. And of course, intermittent fasting can produce the appropriate level of stress through encouraging mitohormesis, which is that adaptability of your mitochondria so that their functions are maintained and they are more resilient. This is the reference for the Phillips and Piccard article that was published in September of 2024. Thank you so much for visiting my channel and listening to this brief research review. From time to time, I'll be posting these reviews of research articles, trying to hit the most current research in Parkinson's and neurodegenerative disease. Have a great day, everyone.